All right. So we'll continue on here. What score does Brady need to score in the top 10%? Now, I was going to introduce you to a new phrase. You've probably heard the phrase WWJD. What does that stand for? What would Jesus do? I'm going to introduce you to a new phrase, WWRD. What would Rick do? Okay? What's the answer to that question? Rick would draw a picture. Okay? So when you're thinking about this, let's go back here. I'm going to erase this previous problem. It's related, but it's in the way. Okay? So Rick would draw a picture. Okay, we're going to draw a picture of a normal curve. Right? If you're in the top 10%, that's the score that Brady wants, right? Brady wants that score. How much? So he wants to do better than what percent of people? 90%. 90%. So you want 90% on the left, correct? To get in the top 10%. Okay? So here's the deal. As we go back to this table here, let me share my screen. Okay. This table works the same way as does your book. Okay. It's always shading to the left. So what percent of the data do I want to the left? I want 90%, not 10%. Okay. So remember in the table here, so instead of looking at the z-scores, I'm going to be looking here. Okay. And I want to find 90%. So we've got 89. Ooh, that's pretty doggone close, right? That's as close as you're going to get to 90%. Do you see that? Now the question is, Brady, what is the z-score associated with that cell that I just highlighted?
1.2.
1.2.
Standard deviation.
It's not just one. So 1.20 is that number there. Okay.
Oh,
You want this number, so it's 1.28.
okay.
Do you see that?
Yeah.
Okay.
So what does that mean?
So what that means is Brady needs to be 1.28 standard deviations above the mean, and the mean is 0, right? Okay. So that's what Brady wants to be. Now we have to convert 1.28 back to an SAT score. And remind me, what is the SAT mean? Mean score? 500. So it's got to be numbered greater than 500. Okay? So now we've got to figure out this number. How do we find that number? What equation do I use?
Use that same one, but you put
Use the same
1.28.
equation, but now I know my z-score, right? Okay? All right, so let's stop sharing and not stop the recording this time. Okay? All right, so I need to convert 1.28 to an SAT score, and I'm going to use this equation here, right? Okay? So let's have Ashley take it away because it sounds like she knows what she's doing. Okay? So I'm using this equation. So z in this case equals
1.28.
1.28 equals, what's x?
We don't know.
We don't know what x is. Okay? Minus mu.
Which is 8.
No,
Or
we're doing the SAT exam.
500.
500. Okay? Divided by
100
100
over the square root of 1.
over the square root of 1, because there's only one Brady, right? Were your parents glad there was only one Brady?
Well, my sister married a Brady, so there's actually 2.
Oh, there's 2.
You count that. There's only 1.
There's only one of you, though. Okay? All right, so now we have to do just a little bit of algebra. So Ashley, how can I, so the square root of 1, that's just going to go away, right?
Right.
So how do I do the algebra to solve for x?
So you add, no. Yeah?
Oh, can you split them?
Well, we need to get this out of the denominator first, right?
Yeah.
How do I get rid of that?
Times it by 100.
Yeah, so I'm going to by both sides by 100, so that will go away. And then I'm going to
Add 500 over to the other side.
add 500. So X equals 100 times 1.28 plus 500, right? 100 times 1.28 is 128 plus 500 is 628. Okay, so 480 has to get a 628 or higher in order to be in the top 10%. Okay, does that make sense? Okay, so you can use this chart both ways. And in fact, let me show you something else. I didn't show it to you kind of on purpose because I wanted you to see that. But I will show you that at the bottom of the chart here, oh, not on the bottom, it's over here on the right tail. If you're doing a right tail test and you want 10% here on the right, the number is 1.28. If you want 10% on the left, it's negative 1.28. Okay, so those are common. But what if you wanted to score in the top 25%? So now we're going to do the same thing, but we're going to do it with Suzette's score on the ACT. We want to be in the top 25%. Okay, so let's pick on, how about Gage? Can you help us do that? Stop sharing for a moment. Well, no, I won't. We'll keep sharing for a minute. We're going to score in the top 25% of the ACT. So what do we have to find here?
I don't know. I'm kind of lost with this.
Okay.
So 25.
Okay, so let me ask you the question when you're lost. WWRD.
Draw it out.
WWRD. What would Rick do?
Draw it out.
Draw it out. What am I drawing? What am I drawing?
Draw it out. Let's do
We're going to draw a bell curve, right? What's the mean of my bell curve?
1?
No, it's 0.
0.
But my standard deviation is 1, right?
Yeah.
Okay. And I don't really need that here, but I want the top 25%. So how would I represent the top 25% on this bell curve?
0.75.
I'm going to draw a line here on the right side of 0, right? So I want 25% here, and that means how much is over here? 75%. Okay? So I'm going to go back to the chart that I was just looking at, and the question is, do I look at the 25% or do I look at the 75%? 75%. Why? Because when I look at my chart, what does my chart tell me when you look at the picture here? What's shaded? It's always the left side is shaded, right? So I've got to look at the left side. The left side here is 75%. Okay, so I'm looking for 75%. And doggone it, it's not in my table here. Okay, so I'm going to have to go fishing for this one. So I need to go find 75% over here. So where is 75%?
Right.
Let's see, we got 77, 76, 75. Oh, it's right smack dab in between those two, right? Okay, so if it's really, so in this case, look, it was really close to 90. So that was close enough. These are like right smack dab in the middle, aren't they? Okay, so what's the Z-score associated with the top 25%? No, it's not those two divided by 2. 0.675, very good. Okay, because we're on the 0.6 line here. We're 0.6 standard deviations away. And since it's in between those two, we'll split the difference and say 0.675. That make sense, Lana?
Yeah, that makes sense. Yeah.
Okay. All right. Okay, so my Z-score is not, so we're looking for something that is 0.675 standard deviations away. Let's stop sharing again. Okay. So in this case, what is the equation that we need to figure out how Suzette scores the top 25%?
It's going to be 0.675 equals.
We're going to use this same equation here, right? 0.675 equals,
Don't know.
we don't know the x. That's the score we're looking for. Minus ACT mean is 21 divided by,
Oh, it's 18,
oh, it's 18, sorry.
Oh, sorry, I was
18. Okay, divided by 6
over the square root.
over the square root of 1, because there's only one Suzette. Are your parents glad about that? Is anybody married into the family and brought another Suzette in? No? Okay.
Trust me, it sucks.
So this is funny. My name, I'm Rick. My wife is Wendy. She has a sister, Becky, who has a husband, Jim, who has a brother named Rick, who married a Wendy. So how's that for weird? Okay, it's even worse than Brady, huh? Okay, 2 Rick and Wendy's. All right, so how do we solve this equation? Let's pick it on Brenda. You know the square root of 1.
Oh, base square root of 1.
That just goes away. That's just 1, right? How do we get rid of this 6?
U times both
Times
sides.
both sides by 6. So I'm going to take that number, I'm going to multiply that by 6. And then I'm going to
Times that out. Oh, plus 18.
plus 18. Now we can plug it in my calculator. X equals 6 times 0.675 plus 18, and that equals, who's got a
I
calculator?
got 22.05.
22.05. I'd probably leave it at that. They only do whole numbers, but yeah. So Suzette, you need to score the 22 to get in the top 75%. Okay, or 23 if you want to be there. Okay? Does that make sense? Okay?
You have 21?
Okay. Now, should we do another one this time on the computer? Because I know how much you guys love the computers.
Is it easy? Is it easier on the computer?
Is it easier on the computer? Well, we'll do it and then you can tell me.
Okay.
Okay? But having said that, I still think you're going to need to remember this phrase.
Yes.
Okay? All right, so here's what we're going to do. I'm going to try to write on a computer. Let's find a new blank page here. All right, let me share. Oh, I hate this. Okay, so let's pretend that let me make this bigger. You want
It's a Thursday.
to know the probability of finding a toddler 35 to 38 inches tall. You know the height is normally distributed with a mean of 38.72 inches and a standard deviation of 3.17 inches. Okay? So, what haven't I picked on? I think I've not picked on Audrey yet. Okay? How do you start this problem?
You plug in the numbers into equations.
Okay?
So it's going to be
What would you do before that?
cross section.
Ah, very good. Okay, you guys are learning. Okay, let's draw a picture. Okay? Here, I'll keep the equation there. Okay, what am I drawing a picture of?
It's going to be a little bell.
A bell curve. Okay, and how tall is the average toddler? 0 on the standard normal curve. How tall are they without the standard normal curve?
38.72.
38.72 inches, right? Okay. So you can use either scale or both scales. If you want to draw it like I did, then you can kind of compare the scales. Okay? All right, so now 35 to 38 inches, are these taller than normal toddlers or smaller than normal toddlers? Small, they're both smaller, right? So they're going to be on this side. So we want to know 35 to 38 inches tall, right? We want this area here. These are smaller than average toddlers. Okay? So how do we find that area? Well, you know, in fact, you said it before you said draw the picture.
Oh, plug in my numbers.
Plug in your numbers, okay? We're going to have to plug in 2 sets of numbers, right? So I'm going to need 2 equations here, not just 1. Okay?
And why is that?
Because I want the area below 38 and I want the area below 35, right?
Okay.
Okay? All right. So now, what do I do?
I want to say it would be like 35 equals X.
Is 35 the z-score?
No, that's what we're finding, right?
That's what we're finding. So 35 is what letter in my equation? It's X, right? Okay. So z equals, you said 35 or 38?
I mean, either.
You're going to need to do them both, right? Which one do you want to do first?
35.
35
Minus
minus
38.72.
38.72 divided by, no, you can't see because when blocking, aren't you?
So you divide by 38.
How's that?
3.17.
3.17 divided by, what's my n?
Square root of 1.
Yeah. It's always 1 in this section,
Yeah,
right?
so it's 1. It's always 1.
In this section.
Okay.
In the future section, it won't always be 1.
Okay.
Okay? So that's going to give me negative 3.872 divided by negative 3.72 divided by 3.17, and somebody can do that. Shire, can you help me with this other equation?
Yes.
Okay?
It'd be 38.
38
38.72.
minus 38.72.
And divided by 3.17 divided by the square root of 1.
So that's going to be negative 0.72 divided by 3.17. Who can punch these through and tell me what they are? Or here, tell you what, we'll show you how to use the computer now. Okay, so we've done all this work here on paper. Now let's transfer it to the computer, okay? Now, by the way, I used to say that you could use paint in the testing center, and then the testing center told me that there's a way to cheat with paint. And I did not know that. You have to be pretty sneaky, I think. So they will not allow you to use paint, okay? But if you would like to draw a picture, let me show you how to do this on here, okay? You go to Insert, and you go to Shapes, and let's just pick a line here. So I'm going to draw a line here. Or you can use scratch paper. And then if you click on this squiggle curve here, click on the line, and then click and click. That's a pretty good looking normal curve, right? And then you press Escape to end. That's pretty good, huh? Okay, and so then we can draw some more lines here. That's your mean. And you can type here, that's 38.72. And then we can also draw some more lines, insert our shapes, boom, and draw another line, and boom, and that's 35 and 38. And you can add some spaces so that they go over there. Okay? So that's how you can do that. Isn't that cool? Okay? So you can draw with Excel, but do not open Paint or I will get an email saying that you're trying to cheat. Okay?
So can you like, well, how is that cheating?
I don't know, but they said
Oh.
just don't do it. Okay, so we need to find these two z-scores. So z equals, and I'm going to write it out here, 35 minus 38.72 divided by, and then if you want to underline that, over 6 over the square root of 1, okay? So that equals 35 minus 38.72 and divided by 6. So if you take this number divided by that number, you get negative 0.62. I guess that's right. Then we're going to do the same thing here.
Yeah, you're supposed to divide by 3.17.
Oh, I got my problems mixed up. There we go, that's better. I knew that number didn't look right for some reason. Okay, so what we're going to do is we're going to copy this, we're going to paste it, and then I'm going to say 38. I'm going to change this number to a 38. And I've got those two numbers. Okay, so when I go back to my picture here, what I've done is I'm saying I want to go from negative 0.22 to negative 1.17. Oops. One equals there. I want to. Okay, do you see that? So now, how do I find this area in between those two lines? Okay, now let me just tell you that Excel works exactly the same way that your chart works. Okay, there's a command here, and it's called norm equal. There's two of them. Norm as dist. One of them has periods. This one here has periods. This one here does not. The one without the periods is easier to use than the one with the periods. Okay? And so what you can do is you can say, okay, well, I'm going to pick that number here. And it tells you that to the left of negative 1.17, in fact, you can go more than 2 digits. Now you can use all the digits you got, right? So the computer's actually going to be even more accurate than the table. Okay? 12% of the data is to the left of 38. Okay? And I'm going to do the same thing again. Norm as dist of the 0.227. Okay? And I get, you know what? My numbers are backwards. This should be negative 1.17, and this should be negative 0.22. Oh, why did it put an equal sign? I didn't put an equal sign there. Okay. All right, so it's telling me that I've got 41% to the left, and I've got 12% to the left. So how do I find out what's in the middle? So I just subtract the bigger number, okay? So I'm going to take the bigger number, 41% minus the 12%, and I'm going to get almost 29%. So about almost 29% of toddlers should be between 35 and 38 inches tall. Okay? So you can do it both ways.
So doing that, can you, so norm, what was the?
Norm as dist. Now, by the way, on that formula sheet that I gave you for the test, it's also posted in the announcements. And so it's on your sheet. So if you want to print that out and look at it so you can use that. So here's what I would recommend for your homework. Homework to do Tuesday. Now, on some homework problems, I'm going to ask you to use the 68, 95, 99 rule. On some problems, I'm not. The ones that I'm not, you can either use the chart or you can use Excel. My advice to you, so that you don't take 10 hours in the testing center, is to do your homework twice, once on paper with the chart, once again on the computer with norm as dist. Okay? You should get your answers should be very similar to each other. If you do your homework twice, you will probably do much better than if you only do it on paper, because you will not know how to do computer part, okay? So who's going to do their homework twice? Oh, Brady, why did you take your hand down?
Well, I have a question. So will we be graded on doing it by hand? Because I know the last test, we didn't do like meeting and meeting by hand. We just had the questions, like just the basic questions. We didn't do any math. So will we be graded on how to do this in Excel and by handwritten?
Yeah, I'll probably have both.
Okay.
Yeah, that's why I wanted to show you how to do it both ways.
I will
okay?
do it both ways.
So that's why you should do your homework twice, not just once, okay? Use the computer, use paper. You need to know both methods only if you want to do well. But if you want to fail half the test, just do it once. Okay?
Will class be here next Tuesday, or are we gonna try to computer lab?
You know what? Let's plan on the computer lab. I probably won't know till Monday though. I can try to reserve it, but they hassle me when I reserve it. I'd rather just show up.
Okay, cool.
So I'll post hopefully on Monday or Tuesday morning, check and make sure. But yeah, ideally we'll be in the computer lab,
Okay, sweet, thank you.
okay?